Alright guys, today we're going to find the y-intercepts of any of our parent functions. And what we need to remember is that any y-intercept crosses the y-axis. And what happens when any point lies on the y-axis is that its x value is 0. So to find that y-intercept, all we really need to do is substitute 0 in for x. We find f of 0, and that gives us our y-intercept. And we can do that by hand. We'll do that first. We can also use the calculator, but to do it by hand, substitute 0 in, 0 minus 3 squared plus 2 would be our y-intercept. Following our order of operations, we need to remember to do the inside the parentheses first. That's negative 3 squared plus 2. And again, keeping in mind our order of operations, that's 9 plus 2 is 11. So our y-intercept for this function would be 0, 11. And we could put that on the graph if we had enough spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't have enough spots on this graph, but that would be a point, again, along the y-axis. And similarly, if I wanted to find the y-intercept of this absolute value function, again, all I'm doing is looking for f of 0, finding the value when x is 0. In this case, that would be the opposite of 0 plus 1. Plus 3. I do inside the absolute value symbol, that's 1. The opposite of 1 plus 3 is 2. So my y-intercept in this case, f of 0, would be 2, which would be right there on my graph. I also want to keep in mind, however, that I could use the calculator to find this, the y-intercept in any function that I'm looking at. And the way I do that is I hit second table, and all I need to do is look under the table when x is 0. So in my first column, I look for when x is 0, and I'll see the y value when x is 0. And again, that's my y-intercept, 0, 2. When x is 0, the y value is 2. So I can use the calculator if I have the calculator. Otherwise, I can substitute in the value of 0 for x wherever I see it in the function.